Hey guys, tonight you are going to be looking at recognizing and graphing linear equations. And when we're talking about graphing, we're going to go from equation to table to graph. This is always our safest bet when we don't know what to do. We're always going to fall back to go from your equation, go to the table, and then graph. So let's go ahead and take a look at what this means. Go ahead and title this Graphing Linear Equations, and your essential question is, how do I recognize, and graph? Okay, the first thing, in order to recognize, you need to remember what a linear equation is, and a linear equation is a graph who makes a line. If we go ahead and look at the word linear, there is line in it, so that will help you remember that you're looking at graphs that only make lines. On the lines, those are all called solutions. That's all the points that are on the line. Okay, we are looking from going to an equation, to a table, into a graph. And here's the format that we're going to look at. We're going to look at our list of x values, our list of y values, output values, and then those make our order pairs to make our graphs. Let's go ahead and look at two special types of graphs that don't show up often. I would add these into that side column right there called horizontal lines and vertical lines. They, again, don't show up often, but when they do, they'll catch you off guard because we might not have learned them yet if you don't talk about this format now. Okay, so y equals b is that horizontal. So y is a number, and then the x equals a number is that vertical. Horizontal, look to the horizon. You're going to be looking at the sun setting, look at the sun rising, look at the sun going up across the mountains, something like down, setting on the mountains. Look at the horizon, so right to left. Vertical is that up, down. Let's go ahead and start with our examples. Okay, so as I stated before, we're going to start with our equation. Then we're going to table our equation. And then we're going to graph our equation. So, our equation for example 1 is y equals 3x. So x is your independent variable. What we plug in for x is how we're going to find out y. Here's my suggestion. So here's my table. I'm going to make up 3 columns. My first column is x, my second column is y, and my third column is going to tell me my order pairs. Okay. My suggestion, when you're plugging in numbers to the equation to make that table, here's the 4 that you should choose most often. -1, 0, 1, 2. I want to know what's happening when x is negative. I want to know what's happening at the origin. I want to know what's happening when x is positive, and I'm going to check that with that second one. So that's why I picked those 4 numbers specifically. What this means now is I'm going to plug -1 in for x. So this is 3 times -1 equals -3. Plug 0 in for x. 3 times 0 is 0. Plug 1 in for x. 3 times 1 is 3. Plug 2 for x. 3 times 2 is 6. Now we have a list of input values. These are your in and these are your out values that make up your ordered pairs list of x's and y's. So our first order pair that I said to take a look at, not that it's the first one because solutions have infinitely many on this line, okay, is -1, -3. Next one, 0, 0. Third, 3, 1, and fourth. Oh, I'm messing this up. 1, 3, x goes first, then y. 2, 6. Here is the number 1 mistake I see most often on your papers, hence why I did that purposely. Okay, you don't want to flip-flop your orders. It always goes x, then y. Always, always, always. Okay, now, again, equation. We made some of the table. We won't be able to make all of it, but we took those 4 points that I said you should use, and now we're going to graph it. Remember how to graph. We're going to go -1, -3, -1, -3, 0, 0, 1, 3, 2, 1, 2, 6, 1, 2, 3, 4, 5, 6, and we have graphed it. Okay, all we need to do now is connect our dots, and I'm going to use a straight edge to make sure you're using a straight edge because it's super important. My straight edge is not good, so let me redo. Use a straight edge to connect those dots, and then it is important that you put those arrows because it extends past what we see on our graph. All right, that is how we graph, how we go from equation to table to graph. Let's go ahead and try this with our second example. I'm going to pause my video and erase everything that's on my paper and resume when I'm ready. All right, so we are going to be plugging, again, I suggest these 4 numbers, so because you don't want them to be too crazy and too big, we're going to plug in -1 for x, so -1/2 times -1 plus 2. -1/2 times -1 is 1/2, plus 2 is 2.5, 2.5. That means our order pair for this one is going to go -1, comma, 2.5. All right, 0, -1/2 times 0 plus 2. -1/2 times 0 is 0 plus 2 is 2. Our order pair is going to say 0, comma, 2. -1/2 times, again, I'm picking from the equation that's listed above, 1 plus 2. -1/2 times 1 is -1/2, plus 2 is -1.5. Okay, not negative, just 1.5. 1 comma 1.5 and 2. Do you guys see the pattern that's going on in our table? We're going down by halves. I can already say that this one is going to be 1 comma 1. Sorry, 2 comma 1. 2 comma 1. Now we're ready to graph. Okay, -1, 2.5, 0, 2, 1, 1.5, 2, 1. Now using a straight edge, I'm going to connect those dots. Using a straight edge, want to go all the way to the end of each window. So I'm going to go back and fix my line over here. Good. Add in those arrows telling your reader that it extends past what you have on your paper. And you did it. You graphed it. All right. I'm going to go through and look at these last 2 examples with you. These are our special examples. We have x equals a number. This is one of those special ones. That means in our table, x is always going to be -4. Always. There's no other option. And then y is going to be everything else. Oh, sorry. Y is going to be everything else. 0, 1, 2, 3. So, is this, I want you to think to yourself right now, a vertical or a horizontal line? Let's go ahead and graph it and look. X is always -4, so always going to be right here. X is always -4. Vertical or horizontal? If you're thinking vertical, you're thinking on the right track. Use a straight edge to connect those dots, and you did it. You graphed it. Now let's go ahead and look and see when y is -1. That means on this table right here, the 2 ways you'll see table is up and down and right and left, that y is always -1.5. Always -1.5. So on our graph, where do we have y is -1.5? Right here. So where is y always going to be -1.5? Going along that horizontal. So here's our last special one, and I'm going to use a straight edge to connect these points right here. Oh, that was a horrible. I should shift it down. Let me see if I can shift it down. Oh, nope. Okay, so there we go. Try this button. Shift this down. Oh, it's crooked. I hope yours looks better. It definitely should look better than mine. Let's go ahead and get to that on your own part. And you go ahead and graph these two. When you're ready to resume, go ahead and press play. I'll be waiting. Thanks for pressing pause. Here's what you should have graphed. Okay, super important for number 2 since it's a scenario that you include your units of measurement, and this little fraction, this little line here tells you, reader, that you're jumping up to 100. So the graph is not scaled properly. You're telling them that by that. Okay, your equation, you should have made your equation in order to get to the graph, and I should see tables on your paper. Okay, go ahead and answer that essential question and take that checkpoint. Thanks, guys, for tuning in.